everyone, welcome back to the STEM Space at Home. I am your host, Mechanical Engineer Aspen Meineke, and today we are going to be building our very own space lander. Ever wanted to travel in space? Well, it isn't just science fiction. It's happening in real life and happening right now.
Ignition sequence start. All engines are running.
We have taken tremendous steps.
We choose to go to the moon before this decade is out.
We have achieved the earth-shaking, the breathtaking, the groundbreaking,
One small step for man.
and left a mark in the heavens. Our successes build one upon another and amplify what is possible.
The dawn of Orion.
It's time we take the next great leap.
Astronauts are people trained to travel in space, so they know how to fly spacecraft, to deploying satellites, and even doing science and engineering experiments in space. One of the qualifications in order to be an astronaut is to have a STEM degree. STEM stands for Science, Technology, Engineering, and Math. And this can include fields like video game design, robotics, 3D printing, medicine, and microbiology. NASA's goal for its new class of astronauts is to first travel back to the moon, where we can create a lunar base, which is a place for humans to permanently stay on the moon. After that, our next destination is Mars.
We're building the next chapter of American exploration, returning to the moon to stay, so we can go beyond to Mars, to expand what's possible and further our understanding. We are going. We are training, testing, pressing our pioneering spirit into every component, defining our resolve with every line of code, and securing our success with every welcomed partnership. We are NASA. And after 60 years, we're just getting started.
The distance from Earth to Mars is 200 times farther than it is from Earth to the moon. Because the journey is so long, NASA is currently sending robots to Mars, like Curiosity and its newest robot, Perseverance. That way, we can determine what Mars is like before we send humans there. They're studying things like the soil and its environment and sending data all the way back to Earth.
Mars 2020 will be seeking signs of ancient life in the rock record of Mars.
What we're trying to do is to rove around the surface of this unknown planet.
Collect samples
Process the tubes as they come back.
To look for things that we call biosignatures.
so that eventually we can bring those samples back to Earth and determine for the very first time, did life exist on Mars?
Not only is it a really far trip to Mars, but it's also just as challenging to actually land on the planet because of how thin the Mars's atmosphere is. So what exactly is an atmosphere? An atmosphere is a layer of gases that surrounds a planet and contains the air that we breathe, protects it from the sun's radiation, and makes the climate livable for humans. It's similar to the peel on the outside of a lime or a lemon. So limes and lemons have a thick skin on the outside of it. This protects the lime fruit on the inside of it. So if we were to drop this at the grocery store, the skin protects the fruit from germs and becoming damaged, just like the atmosphere protects planets. So how many times thinner is Mars's atmosphere than Earth's? Do you think it's 5 times thinner, 10 times thinner, or 100 times thinner? If you guessed 100 times thinner, you're right. Mars's atmosphere is a lot thinner than on Earth's, and it's why humans can't breathe on it. However, since the atmosphere on Mars is really, really thin, there's not enough gas to slow our spacecrafts down. And so we would need to create a device for the spacecraft to use to safely land on the planet. Now, the atmosphere is not the only thing that's challenging when we're thinking of landing rovers or spacecrafts on Mars. You also have to think about the communication period. So when landing a rover currently on Mars, that's called the 7 minutes of terror. And the reason it's so scary is because during these 7 minutes, humans do not have contact with the rover. And that's because Mars is so far away from Earth, it takes 14 minutes for us to send a signal from Earth to Mars. And when you're landing a rover on Mars, that happens under 7 minutes. and so we have to build a rover that is able to land itself on Mars. Here's a video from a NASA engineer talking all about it.
When people look at it, it looks crazy.
Entry, descent, and landing, also known as EDL, is referred to as the 7 minutes of terror, because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0 in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from the ground. If any one thing doesn't work just right, it's game over.
Alright, so your mission today is to build a safe lander to safely land your astronaut on Mars. So today, your astronaut is going to be represented by a ping pong ball, or if you have a marshmallow, something like that, and a cup. Right now I'm using a 3-ounce cup, but you can use any type, any size of paper cup. So I want you to try an experiment. Place your ping pong ball or marshmallow inside of your cup. Hold it out at arm's length. Make sure your arm is straight and the cup is straight. And then I want you to drop the cup and observe what happens. So as you probably noticed, your ping pong ball or marshmallow probably shot straight out of the cup. And you don't want your astronaut falling out of your spacecraft when you're landing on Mars, right? So you need to be able to build a device around the cup to safely land your astronaut and slow your cup down enough so that the ping pong ball or the marshmallow does not fall out of the cup. So my hint for what I want you to start with is take your paper cup, and right now I use a half sheet of construction paper and I taped it to the bottom of my cup. This is going to be my platform for my space lander. Your building supplies for the challenge is going to be tape, cotton balls, scissors, bendy straws, and more construction paper. The first step of the engineering design process is to identify our problem. So our problem is that we're trying to land our astronauts on Mars and we can't do that safely. So how can we make our lander safer so we can land our astronaut on Mars and our ping pong ball can stay inside of the cup? So your design constraints for this challenge is that you can only build below the platform. So you cannot tape anything on top of this piece of paper. You can only tape below and underneath the platform. You also cannot cut the cup, and you cannot place anything inside of the cup. The only thing going inside of your cup should be your astronaut, which is your ping pong ball, marshmallow, whatever you decide. So the next step of the engineering design process is the brainstorming phase. So this is where you draw out your design, you think about what it would look like, and when you're doing that, I want you to keep this experiment in your mind. So I want you can do this at home, take 2 sheets of paper. They need to be the exact same type of paper, and I want you to crumble one into a ball. So take this, crumble into a ball, and then take your piece of paper, leave it normal, and I want you to hold these 2 out, straight out with your arms, and I'm going to count down on 3, 2, 1, and when I drop it, I want you to see which one lands last. So which one is falling the slowest. So 3, 2, 1. All right, so the large piece of paper is the one that landed last, and this fell the slowest. So this might be something that you want to use in your design since we want our cup to fall slowly. The reason this large piece of paper fell slower, unlike this guy right here, is that you have a larger piece of paper which is going to create more air resistance. So there's air all around us. And so if you have a larger object falling through the air, it's going to be slowed down a lot more than the paper ball because it's taking up more space. So a larger piece of paper is going to fall slower than a paper ball. So I want you to think about that when you are drawing and writing out your design. So I hope you guys enjoyed today's video. Don't forget to post your creation on social media using hashtag STEMSpaceAtHome. I cannot wait to see what you guys create. Thanks for watching, and I'll see you next time.